Welcome, everybody. Today we're going to talk about two very important concepts, central tendency and variance. Those two are the backbones of descriptive statistics. It allows researchers to see how their data looks like. You can imagine that you collect hundreds of responses, and once you calculate the mean, for example, and the standard deviation, you can tell right away where the majority stands and how much they differ. The two main tools of describing data are measures of central tendency, which includes calculating the mean, median, and mode, and variance, which includes calculating the variance, standard deviation, and range. They're all very useful, but depending on the type of data we have, we may choose to use a different one each time. So let's get started with the measures of central tendency. I bet you've seen this before, and you thought you didn't know much about statistics. Well, you guessed wrong. You probably have seen this a bunch of times. Maybe some of you know how to calculate it. But why do we need it? That's the big question. And this is hopefully what we're going to try to explore in this course. Okay? So we contact central tendency because we want to find out the most typical value in the data set. For example, you want to find out what is the average weight of health science female students. You go ahead and you interview 100 female health science students and you calculate the average. Then from there, you can assume that the majority of females health science students are somewhere around that average that you just calculated. Of course, the data that we collect is not always going to be perfect. You're going to have extreme scores, might not be numerical, and so on and so forth. That explains the need to have more than one measure of central tendency. So the three main types are the mean, the median, and the mode. We will talk about each one in more detail. But before we do that, let's familiarize ourselves with a few simples. In statistics, the majority of time, anything that is capital or a Greek letter usually refers to the populations, and lowercase letters or Latin characters to samples. Thus, when we refer to population, the number of participants is depicted by the capital letter N, and when we have a sample, we write a lowercase n. This is important, and make sure you pay attention to what I'm giving you in case of a homework or a test. Sometimes you will see a capital and you need to make sure that you're going to treat it as a population. Sometimes the formula does differ a little bit, so you need to adjust accordingly. So always pay attention to your symbols. The mean, okay? So just looking at those formulas right here, you can probably feel like, oh my goodness, this sounds Greek to me, and it is Greek up to a certain degree. So don't get intimidated. It's just simple math. It just looks weird because in statistics we use a lot of simples, but there's nothing difficult about it. The only thing that you have to do in this particular case is simply add all the different scores that you get from your participants. You're gonna have the sum, okay? And then you simply divide by the total number of participants. The resulting number is going to be your mean. So right here, for example, the X bar symbolizes the mean of a sample, okay? So again, I repeat, X bar is the mean of a sample, not of a population. The population is symbolized by the letter mu, okay, which kind of looks like a U with a tail. And the Greek letter sigma here, that means the summation of all x values divided by n. So what are the advantages of calculating the mean? The advantages are many, and that is why we always prefer, if we can, to calculate the mean. First of all, it takes into account every single participant. That means that the final number reflects the scores of all those who participated. As a result, the mean can be used to calculate higher level analysis. Furthermore, it is extremely easy to interpret. Now, the major disadvantage is the very fact that makes it very useful, okay? It can be very susceptible to extreme scores, and since you're taking every single score into account, that can truly affect your outcome. So let's just take an example. And your sample is going to be migrant workers in Guatemala. Okay, so you go ahead and you recruit 10 participants and you ask them how many sexual partners they had thus far. Okay, The scores that you see right here, they're going to depict the number of sexual partners each participant had. So the first one had one, the person number two did not have any sexual partners, person number three had four, and so on and so forth. Now that you have that, you can go ahead and use your mean formula and calculate your average, right? So this is your formula, and this is going to be the steps that you're going to take. So all you got to do is simply sum the scores up, okay? You're going to divide by the number of subjects. So you had 10 participants, and your average is going to be 7.5. I assume that you all know how to calculate this type of math, right? So you just a simple addition, and then you divide by the total number of participants. After the division, you find out that the average number is 7.5. Okay. So based on this, okay, according to this data set, the average man has 7.5 sexual partners in their lifetime. But now let's just see what happens if we add an extreme score. And let's take Will Chamberlain as our example, okay? He supposedly had over 20,000 partners, at least that's what he claimed, okay? Now imagine he is part of your sample. What will this do to your mean score? Okay, let's go ahead and calculate the mean again, and let's see what happens. So you add all those numbers, and then you go ahead and you add the 20,000 sexual partners that Will Chamberlain had, and you find out that now your average is 1,825. Do you think that truly depicts the average number of sexual partners that the average man has in their lifetime? Probably not. Wishful thinking for some, but not even close. Okay. So as you can see here, although the mean is an excellent tool of finding out central tendency, it is very sensitive to extreme scores. Okay. And that's the major disadvantage of calculating the mean, because you went from 7.5 sexual partners to 1,825. The median. The median is simply the middle observation. The only thing that you got to remember is that you need to order your data first and then find the middle point. There are different ways that you can find the middle point, but the easiest one would be to count the number of observations you have, you add 1 to it, and then you divide by 2. You can count up to that number and you got the middle observation, okay? If the number of observations that you have is an odd number, then adding 1 to it and dividing by 2, you will get to the midpoint, okay? If your number of observation is an even number, you will end up having 2 middle scores. In that particular case, all you got to do is just add and find the average of those 2 middle scores. Let's see at an example. So in this particular case, you have 11 scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so plus 1 makes it 12. Divided by 2, you get a 6. Now you count up to a 6. So 1, 2, 3, 4, 5, 6. So 5 is going to be your median value. Okay, I think that is very easy to figure out. So what are the pros and cons, okay, of calculating the median? As you can understand it, it's really, really easy to calculate it, which is cool. But at the same time, it is less sophisticated, okay, which means we cannot really use it in order to calculate more complex analysis, okay. Now, at the same time, though, it gets rid of all the outliers. As you notice, we were calculating from the outside in. That means any extreme scores that we had, we got rid of it. This way, it is less susceptible to extreme scores, and that's what makes median very useful. Okay. The mode. The mode simply means the most frequently observed score or value. All you have to do is look over your data, okay? You order your data and you look over it and you're trying to find which score occurs more than once, okay? And you're trying to find the most frequent score. A data set, of course, can have more than one mode. Now, the question is, where can the mode be useful? Well, let's take the shoe salesman, for example. Okay. When a shoe salesman wants to stock up his inventory, he or she is not interested in the mean or the median. Okay. He's interested in the mode, the shoe size that sells the most. So, for example, if most of his clients were a shoe size 7, 8, and 9, there's no reason to stock up in any numbers that any shoe sizes that they're 11 or 12 or 13, right? But if you calculate the mean, right, or if you calculate the median, you might get a different value. But simply looking at what most people buy, you will get the mode. This way, it can be very useful for certain occasions. Here is also an example of calculate the mode. It is truly, truly very easy. You have a bunch of scores here. You order the scores, and now it is very clear which scores here are being repeated more than once. You have two fives here and two A's, so those are going to be your modes, and this is what it's called a bimodal distribution. So when can a bimodal distribution can be edifying, okay? When can we justify or can be useful, okay? When our population is really composed of two or more very distinct groups. Maybe we do not want to overlook that very factor, okay? Maybe there's simple differences that we really need to take into consideration. And let's just look here at a graph, okay? Again, this is a graph about the number of sexual partners. And as we can see, there's two modes here that truly stand out. You have a bunch of people with 0, and you have a bunch of people with 6, okay? So again, the mode, very similar to the median. It is very unlikely that it's going to be influenced by extreme scores since you're not really taking into account. Okay, so if you have one extreme score, you're not even going to pay attention to that. You're just going to skip over. You're going to find the most frequent values. But again, the major disadvantage is that it's way less sophisticated, okay? We cannot really do a lot with it as far as, using math, since we're not really using math, okay? It just gives you an idea of what's going on with your data, but nothing more than that. And now let's look at variance, okay? So what do we see here? There's a bunch of men dressed like Elvis Presley, okay? The question is, who looks more like Elvis, okay? They all do, but a couple of them look more than Elvis than the rest, okay? So there are differences as to how well they capture the essence of the man they're trying to pretend to be. And that is what a variance is all about, okay? Variation allows to see how homogeneous or our data set is or how heterogeneous it is, okay? So homogeneous simply means similar. Heterogeneous means to be different, okay? The two measures of variation are range, variance, and standard deviation. And as you can see here, we group variance and standard deviation together simply because they pretty much use the same formula, just the one is the square root of the other. Now let's look at this picture and let's see. Would you say that those two participants have high or low variability in height? Okay, take a look. You can very clearly see that there's high height variability. Okay, now how do we calculate the range? It's actually quite easy. You simply gonna get your greatest value and you're going to subtract your least value, the smallest value that you have. Okay, but again, you can imagine what would happen when you have an outlier, such as the case of Will Chamberlain, right? So when we're going back to the example of sexual partners and you're trying to figure out how different the responses are between your responders, and you add Wilt into the sample, right, is going to be very misleading, okay? Because he was really out there, and simply getting 20,000 and subtracting the 0 would not really truly depict the true range of your sample, okay? So yes, range is a very quick way of, and simple way of calculating variance, but at the same time, it can be very misleading in the case of outliers. But here there's another example, okay? So what would be the range here for wins among these teams? So you have Vikings, St. Louis, San Francisco, Arizona, Seattle, okay? And Vikings had 9 wins, so this one would be your high score. And it seems to me that Seattle had the least number of wins, so this would be your least score. So in order to calculate range here, you would simply go 9 minus 3 equals 6. So 6 would be your range, okay? Standard deviation. Standard deviation is represented by S or SD. I would say probably S would be the most proper way to symbolize it. Some people like to write SD simply because it's less confusing. Because as we're going to see, variance is symbolized by S square, and it's very easy to forget which one is what. So the definition of standard deviation is the average distance each score varies from the mean for a group of scores. Okay? The greater variability within your participants, the greater the standard deviation will be, and vice versa. Now let's go ahead and see how we calculate. So this is your formula, okay? I know it looks complicated. Don't fret, okay? It's not that hard. So how do you calculate variance or standard deviation? Because as I said before, they're very, very similar, okay? So S is a symbol for standard deviation equals to the square root of the, remember the sigma, the summation of each x value minus the mean squared over the number of responses that you have minus 1. Okay? So that is the formula. I would highly recommend that you memorize this in order to expedite the process in the case of a test or a homework. Okay? But as you can see here, in order to calculate variance or standard deviation, you are going to need the mean. And that is why this is the very first step that you have to take. So you have your data set. Go ahead and calculate the mean. Then what you're going to do is you're going to subtract the mean from each single score. We're going to see an example to understand, okay? Then you're going to go ahead and square those differences. You're going to sum them up, okay? And that is what the sigma stands for. And finally, you're going to divide everything by n minus 1, okay? You're going to get the square root, and you're done. You got yourself the standard deviation. Now, here I want to show you something else, and that is I would like to explain the reason why we square the differences here, okay? Because somebody might ask, well, why don't we leave it alone? Why don't we just add this and go ahead and use the formula? So this way we do not have to take the square root at the very end. Well, yeah, but let's see what's going to happen. Since you're subtracting the mean from every single value, okay, think about it. The mean is the average of all the scores. So you're taking away the mean from every single score. So what's going to happen is you're going to land right in the middle. That means you're going to end up with a big fat 0. So when you have a 0 on your numerator, there's nothing you can do, okay? You cannot use the formula any longer, right? And let's see, in order to verify what I'm saying. So here your first score is a 5. You will subtract the 6, which is your mean, okay, and you're going to get a negative 1. You have an 8 minus 6, you get a positive 2. 5 minus 6, you get a negative 1, and you can do the math on the rest, but let's just start adding. So you have minus 1 plus 2, that's a positive 1. Positive 1 minus 1, that's a 0. Negative 2, okay. 0 does not affect it, so you have negative 2 plus 1, it's a negative 1. Negative 1 plus 2 is a positive 1. Plus 2, you have a positive 3 minus 3, and you got a big fat 0, okay? So right there we would have to stop. But in math we know that it is totally okay to square our values as long as we take the square root at the very end. And that is what we're doing here, okay? And that is what you get this part of the formula right here. So we're going to take every single difference and we're going to square it. And then we're going to sum it up, okay? So that is the sigma of the differences right here squared. And now we're always going to have a positive number. You have a positive number in the numerator, you can go ahead and do whatever math you like, okay? So in this particular case, we're going to have the square root of 28 over 10. This is the number of responses that you have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 1. based on the formula, okay? And that's going to give you the square root of 3.11. You take the square root and you end up with a standard deviation, okay? Variance. So just like the standard deviation, variance also takes into account every single observation, okay? Which makes it, of course, more precise, okay? The symbol for variance is an S squared. I have to say at this point that most of the students confuse the variance with the standard deviation. Remember that standard deviation is the square root of variance, so no square. The formula is identical. You may either take the square of the SD to find the variance, or you may have to the variance and take the square root to find the standard deviation, okay? So let's see them side by side, okay, in order to compare the two, okay? So what do you think? Just by looking at the formulas alone, which one do you think is easier to interpret? Right here, you having standard deviation, and here you having the variance. Which one is easier to interpret? No square root here, but you have squared values, okay? But here you have original units. Think about it, okay? So in statistics, we always prefer standard deviation. We prefer standard deviation over variance simply because it is represented, it comes in original units. It is very difficult to explain things when it is presented on square values, okay? Now, if you want to know more about that, go on your textbook, page 49, on the 5th edition. If you have an older edition, probably it's going to be a different page. Nevertheless, it's going to be at the very end where it actually compares and contrasts variance in standard deviation. So let's summarize what we covered today. So the three measures of central tendency are the mean, median, and mode. The three measures of variation are range, standard deviation, and variance. Okay, let's have a review question. True or false? The standard deviation provides a measure of how far its data point varies from the mean. What do you think? It is true. And this will conclude our today's lecture. You have a fantastic day, and I will see you next week. Bye-bye.